Hello, everyone. Can everyone hear me all right and see my screen? Just react with a thumbs up if you can. Great. All right. So a bit of background about me. I'm 19, preferred pronouns he/him, and I'm a freshman computer science student at the University of Washington. I'm an international school alumni. Class of 2021. I've been a veteran of Titan Robotics Club for 4 years. I'm also an Eagle Scout, by the way. In my free time, I like to tutor people. That's my freelance little side gig I do. My favorite animal is huskies, and I enjoy hiking, hobby programming, and hackathons in my free time. And I feel really honored to be here today, and I'd like to thank everyone for showing up to my presentation. Early experiences with computing. When I was young, around elementary school-ish, I watched the movies War Games and The Matrix. And I really liked all the scenes where they were quote unquote hacking, for example. And that really got me curious about how did computers work inside? Because I was wondering, was it really like what you saw in these movies where you had these fantastical, three-dimensional landscapes with all of these, visuals. And I started learning programming when I learned batch scripting in elementary school. I remember doing my own research online to find lessons on batch programming. And my first programs were choose your own adventure games. And in middle school, I self-learned Python, Java, and the processing language, which I applied to Arduino platform, which I applied at Rocketry Payload Club because we were using an Arduino device for a payload that went on a model rocket that we set off. And it would collect data such as altitude and temperature, for example, along with other information, and beam that back to our base computer. And in the summer before high school, I took a user experience design class at the UW Robinson Center, and during that class, I applied a bit of creativity and applied my processing.js skills to trying to design good user interfaces, for example, for that class. And that got me interested more on the front end side. Before that, most of my development was back end, of course. And in high school, I found first robotics through Titan Robotics Club. And along with that, I did Angel Hack Hackathons in Seattle. And at those hackathons, for the first year I went there, I worked on a project for reporting bullying, essentially. It's supposed to be a software suite that schools can deploy for students to report bullying on. And the other one was a language processing system that analyzed the sentiment of languages, and it was supposed to be a software as a service solution for organizations and companies to use. And it used AWS's language processing tools to do so. In addition to that, I was an IdeaX volunteer at the KCLS Makerspace in Bellevue, where I helped set up demo equipment as well as maintain it. I was also a teacher's assistant at Smart Coding School and the director of technology at Teams Code. At Titan Robotics Club, excuse me, sorry. Okay, at Titan Robotics Club, I did both programming, mechanical, and scouting there. And this is actually the point where I guess I full on decided that I wanted to pursue software in the future. There, I developed robot software for FTC and FRC robots. I worked on offboard Android vision processing. I worked on a suite for that I worked on the infrastructure that allows Android phones to talk to the RoboRio on the FRC robots, such that the RoboRio does not have to do much load on itself. And I also worked on a mobile port of the TRC attendance logger, which is software that we use to keep attendance, as well as the TRC scouting app, which is used to keep track of game data during our matches. And it allows us to quickly to collate that data and analyze it afterwards using data analysis tools like Tableau. When I was at TRC, I learned robot programming from older students, such as Abe, for example, as well as mentors like Mike, and also from Paul, both of whom are our mentors. And I really liked working in a team of other people and being able to combine my creativity with contributions of others to solve problems creatively. So how's CS at UW? At UW, the CS program is under the CSE umbrella, Computer Science and Engineering, under the Allen School. My first 2 quarters at UW, I found that the quarter system offers a packed but very fulfilling schedule, I guess. The curriculum there is rather rigorous, I would say, but that's just because of the way the quarter system works, because they have to cram a large course into 1 quarter. So before you know it, you have the midterms going around, and then you got the finals in. The community there is diverse and friendly, and the staff are great, and they're very helpful too. They're always there for you. You can email them and they usually get back to you very fast, in my opinion. And 2 of the staff I've worked with that are especially great are Professor Hunter Schaefer, who taught me CSE 143, which is the 2nd introductory course for Java programming, and Robbie Weber, who's currently my professor for CSE 311, which is a discrete maths course that it connects mathematical foundations of computing, and tries to connect it with application. At UW, there's also ample study resources, especially for CS, for example. We have the IPL where we can get extra support on programming from experienced staff here, and we also have free study centers for various other disciplines, and they're all free. For example, there's like free physics tutoring there, free math tutoring. For pretty much every subject, we have a study center there. We also have career fairs every quarter, and those are a pretty good way to get connections, as well as know the tech scene around you right now and what's relevant in the industry. There's also a diverse selection of extracurriculars, such as Robotics Club, for example, along with, there's actually, for example, we have Underwater Robotics Club, which is under our Husky Robotics team, if I recall correctly. We also have like game development clubs at UW as well, along with many other clubs there. And I strongly recommend you to join one of them. They're very fun and very educational, of course. Very good way to make connections. And that's all I have to say so far about CS at UW. Now I'd like to move on to questions. Does anyone have any questions about college, for example, or CS at UW or anything like that?
You mentioned several experiences that you had with coding throughout middle and high school. So notwithstanding the robotics club, how did you encounter those opportunities?
Can you please repeat that?
You mentioned several activities that you did related to coding throughout middle and high school. So I'm curious as to how you encountered those opportunities.
Oh, sure, I can go back into that. So when I was in middle school, I guess my first introduction to applying computing to hardware, for example, was in Rocketry Payload Club, and they put up posters around the school, and from that I joined. But right around that time, though, I was also learning processing.js on my own. And from that, I came to, I guess, like it got me to explore my interests more. So it's just, they had the advertisements up and it interested me and I applied it. Now for the UW Robinson Center class, I actually heard from a few friends I knew that took UW Robinson Center's classes, and I found that was very interesting. That's actually the moment when I fell in love with UW, I guess. I guess it's with how creative some of the courses are, how good at teaching some of the lecturers can be, and also I guess how welcoming the community there is in general. And after that, first robotics, of course, I remember going to, what was it called? High school retreat. And TRC had their skits there, I recall. And they actually brought out like one of their robots, if I recall correctly there. And it really got me interested. And some members of the TRC community actually encouraged me to join. I recall that, for example, Elaine and Katie, who are members of Titan Robotics Club, were there too, and they suggested me to join. I also remember Abe being there, and Abe was also pretty influential in getting me to join. He was also very influential later in my robotics career when it came to software. That's how I found robotics. And when it came to Angel Hack Hackathons, well, I actually saw advertisements for them on LinkedIn, and when I saw, for example, how close their hackathon was, like it was only like a half hour. It was only a half-hour drive. And when I saw how close it was and how many successful ideas they had from their incubator program that became, I guess, larger ideas for, like startups to build from, I really want to go there and see what it was like so I could, get a bit more experience on what the field was like in the future. At King County Library System, I remember when I was in 9th grade, the KCLS came to international school and they gave some demos, and there was a bug, if I recall correctly, on the Arduino software that they had set up on the computers. And I remember helping them remedy that bug. And after that, I got offered a position as a volunteer there. Now, when it comes to, for example, Teams code, I actually knew when it comes to Teams code, I knew a friend who was a director at Teams code, and I helped him work on an automated grading system for the first year. And that grading system was used for the next couple of years, and it's used to essentially like grade code submissions that came up. So Teams Code, it's basically an organization that hosts middle and high school programming competitions. And I helped work on the grading system, the automatic grader for that, because I thought that the manual grading process that we originally used during the in-person contests was tedious, and it created a lot of opportunity for error.
We have a question from someone in chat. They're asking, what advice do you have regarding research opportunities, both in high school and at college?
Advice regarding research opportunities in high school and college. Well, one thing you could do here is a lot of colleges have their faculty lists publicly on their website, right? Like if you want to do research with, let's say, the CS department at UW, you can look that up on the Allen School's website, and you can see the list of all the UW, like you can see all the professors, associate professors. So you want to email as many of them as possible, asking them for opportunities. You could link them to your LinkedIn, post a resume on there, and just try to email as many of them as possible. Not all of them will reply, right? Like oftentimes they're very busy with other things, but if you reach out to a lot of them, it's almost guaranteed that eventually you'll find someone that does have a research opportunity. And oftentimes they'll take you up because of, I guess, how it seems a bit ambitious actually trying to do this from high school. So like when they find someone in high school, like actually like taking the effort to reach out there and look for, I guess, opportunities, they really like it. It's the same way in college. In college, one good source you can actually go to is your professor. So if you have like a particularly, good CS professor, you could look them up online and see what they're working on right now. Like you could look at their past articles on ResearchGate, let's say, and that gives you a good picture into, I guess, what they've done in the past and whether that interests you. And if that interests you, you can reach out to them for sure.
We have another question from Will. They're asking whether or not your experience with Titan Robotics Club was good preparation for the courses that you're taking at UW right now, and if so, in what ways?
I'd say they definitely have been a good preparation for what I've been doing at UW. For example, at robotics, I got to apply not just programming, of course, but also other disciplines such as math and physics in doing what we do. And in my first quarter at University of Washington, I took a physics course, that's Physics 121, that's mechanics. And I also took CSE 143 at UW, which is introductory programming in Java, along with calculus. Now at robotics, I actually studied ahead on calculus on my own in order to apply calculus in certain subjects, such as, for example, when we use PID control, that made me learn a bit ahead on, for example, differential equations as well as integration techniques, which I used to, I guess, more deeply understand what our software was doing. And for example, in CSE 143, I continued using object-oriented programming to implement certain software. And I find that my experience developing software for TRC has definitely helped with that. Like it's given me the, I guess, the mindset that you need to like break down a large program into smaller sub-problems to solve, and from which you can connect back into a big program.
Are you continuing your robotics experience at UW?
At UW, I have. I'm currently looking at Titan Robotics. At Husky Robotics at UW. I have not had the time to reach out yet due to my current schedule, but as soon as I become free, I plan to apply and participate in next season's competitions.
So, if I recall correctly, you developed a few apps or softwares on your side as part of your hobby programming. Can you get into some of the projects you've done there?
All right. Some projects I've done for hobby programming. Thinking about it right now. Well, there's actually quite a few, but one thing I could talk about would be this. Well, I guess what exactly are you counting as hobby programming, for example? Because when it comes to hobby programming, I've made things like physics simulations before. I find that very fun to make. For example, I remember making like rigid body solvers for like collision resolving, as well as like projectile motion simulations and stuff like that. I really enjoyed applying my programming to that because I find that physics and programming go hand in hand, for example, because both of them, you have to use the kind of problem solving skills that, apply to programming. Like you're taking a large problem, breaking down into steps, like what do we know? What do we need to find? What means do we have of like trying to get there? So I find that it just goes hand in hand. On the other hand, if you're referring to hobby projects as anything I've done in my free time, for example, including things I've done at hackathons, I guess one of these things would be the content classification system I helped build for text. And I find that's interesting because that was actually my first peek into like machine learning. And I find that's an interesting field because like it's just so different from all the other programming you do. Because all the other programming you do, right? there's hard logic in your program, right? Your program, it's always predictable. But when you're conducting machine learning, you're essentially trying to find a way to let the computer take the lead from you. And when you see the results of what you've built, it's very satisfying, I guess, to see a computer learn to do something in its own way, and also to apply it. Because that project I made, it was supposed to be for identifying, for example, I guess, potentially offensive text, such that organizations that use user contributed data can filter out, for example, like toxic messages easily before they get sent. And I guess it's just going from, I guess, from a conceptualization to like testing it, it's just satisfying, I guess. And I really like doing it.
So you mentioned being like really into physics and then like machine learning. So I know that plans tend to change as the years go by, especially at college. But as of now, what do you want to do after you graduate from college?
That's a very good question. My current interest would be cybersecurity, and that has a lot of tie-in to the current classes I'm taking right now, which is discrete math, for example, where I get to learn, mathematical proofs, which can be applied to cryptography, for example. Like, how do you make sure an encryption algorithm is effective, let's say? Like how can we prove like a certain method of, let's say, like prime factorization works? Like, all of that can be answered using discrete math and number theory. And from the same principles that I applied doing, for example, like trying to like solve physics problems computationally, or applying machine learning, for example, trying to break down a large problem into small steps, this is the same way. And that's what's got me interested right now.
You also mentioned doing some hackathons in the past. So can you get more in detail about like the specifics of each one, like what you did, things like that?
All right, sure. For the first hackathon I went to, I believe that was in the summer of 2018. This was Angel Hack in Seattle. And essentially, for those of you who don't know what a hackathon is, it's basically a place where you get new resources to create whatever you want to. And then at the end of the hackathon, you get to present your project to a board of judges, and they get to judge your project. So at the first hackathon I went to, which is Angel Hack, I remember building a system that allows students to report bullying to their schools. So it would be a software as a service that schools would, for example, that school districts could purchase as a subscription. And then students could then, report instances of bullying to their school for further handling. And the system would allow you to submit, for example, anonymous reports versus, like confidential reports, for example. And that was the first project. And I did that to practice my full stack development skills. And in my second year, I went to Hackathon. I built a content classification system for text that allows you to filter out toxic text versus non-toxic text. And that was also intended as a software as a service solution. And when I used the second year, I used Amazon's text processing tools to help build it, because Amazon was offering like free. They were offering like free trials of this software to anyone who went to the hackathon. So it's a good place to learn new things and also work with a team. In my second year, I worked with a team of 2 other people to build the infrastructure that lets the software, I guess, take submissions and return results.
So right now, day to day, what do you do as it pertains to coding?
As it pertains to coding, sometimes I like to, I guess, sometimes I like to apply programming to my courses right now, because in CC 311, it's less of a programming course as much as it is a discrete math course, but you can still apply programming to CC 311. For example, you can like create like a program to, let's say, like generate like a truth table, for example, for a certain like propositional logic statement. And then you can like recursively like evaluate like each possibility. Like if this is true and that is true, then this result may or may not be true, for example, and so on and so forth. Like you can like recursively like evaluate the statement you're taking in, and then you generate the truth table. That's a pretty good little programming challenge you can do. And another thing, some other things I've been working on other than that are just, other physics simulations, I guess, as I've been doing for electrostatics and other types of electromagnetism related phenomena. Because right now I'm taking a electromagnetism focused physics course, and I like to continue applying my programming skills so that they remain fresh, while also, I guess, touching up my academics.
So how do you balance time? It sounds like doing all this coding might be really time consuming, especially at college.
Yes. And that's a very good question. What I like to do here is create a planner, I guess. And this is, sorry, I don't think the camera can see it very well. But essentially, I like to create a planner like this right here. And I like to check off things as I go. And I also, essentially, I like to prioritize things on this planner. So based on how close something's due date is and how much workload I'm expecting from it, I rate these tasks. I'm sorry, it's not showing up very well. From like, for example, like 1 to 5 stars, with 5 stars being the most urgent and 1 star being the least urgent. And then I can do them in order like that. And then from there, I kind of limit myself to how much work I actually do each day, because it's easy to get caught up and then like get overwhelmed for the rest of the day because you spent too much time working on one thing. Like, so you want to avoid burnout by making time for yourself to, I guess, work on other things and also to socialize and whatnot.
I wish I did that, honestly.
I mean, it's better to start now than never, right?
I mean, you're telling me that after I went to bed at 5 this morning. It's okay though.
Amy is asking,
what sort of classes do you recommend in high school to prepare for college and programming focus?
to prepare for a programming focus in college, I would recommend, for example, taking an introductory programming class. Any language works, right? It doesn't really matter what language you learn. Rather, you're trying to get the foundations in for programming. So I'd recommend, for example, taking a Python class or a Java class, because any one of those classes will give you the foundations that you need to, I guess, think like a programmer, right? To like break down a program into smaller steps, and then make like a and then make like a complete solution to a problem from there. And one thing I recommend doing here is it's actually to do your own learning, because oftentimes, because sometimes school courses, they want you to go at their pace, but not your own pace, right? Like some people like to learn, slower but more in depth, while other people like to, I guess, like learn how to tie everything together and then like, explore the in-depth things through application, for example. So I just recommend buying the programming books on your own and then studying them. Like, for example, when I self-learned Java, I used this book. It's called Building Java Programs by Stuart Regis and Marty Stepp. And this is the same book that the UW uses for their curriculum, and it's a very good introduction to programming. I also have when I learned Python, I used this book called Python for Kids, and that's also a pretty good way of applying, for example, like Python programming to like making games, for example. Like, I guess just go with the best way that works for you, right?
We have a few more questions in chat.
Yeah.
Isaac is asking, so knowing that you have experience in multiple computer languages, which one do you think will be most used or most impactful in your future?
The most used or most impactful language in my future? That's a very good question. Well, I guess if I stick with my current path that I'm planning on to pursue cybersecurity, then the languages that will be used a lot would be. That's a very good question. Well, I guess for example, for cryptography and low-level stuff, you're going to be using a lot of C and C++. For example, to write native code that compiles for your machine and also runs fast. On the other hand, I know that Java is being used more and more in embedded applications, for example, as well. So I expect that'll be used a lot. Other languages, giving it a thought. Well, of course, Python will still be used for a lot of things. For example, you can use it for proof of concepts. You can use it for, like simple scripts to automate stuff. I guess I'll just say Python, C/C++, Java. I mean, Java's got plenty of, I guess, cryptography libraries built in, and it's used for a lot of secure applications. For example, I know that banking uses Java a lot, for example. Like if you have a credit card, the little chip on your credit card actually runs a miniature version of Java for Java card. And in this case, it's still powerful enough to handle the cryptography on your card and do it at a fast speed. So I guess we could see Java could be used more because of that, I guess, emphasis on security, but we also got C++, which has been around forever, and also Python.
Amy's asking if there are any accessible online resources you can recommend to students.
Accessible online resources. Well, I remember I used Coursera.org to learn some things, like they have some C programming courses there, if I recall correctly. Also, I know that I'm trying to remember. If I recall correctly, Harvard released like a CS course a while back that's free for anyone to take. I'm trying to remember what's called. Was it CSE? No, CS 102 or something. Let me go pull it up right now. The CS 50 is the course. Introduction to Computer Science, and it's an online course. It's completely free, 10 weeks long, and it's pretty good for like a quick run through of many programming languages. Like you get to learn like C, JavaScript, SQL. You also get to like learn like markup languages like HTML. You get to learn CSS, PHP, all of those. And if you want to learn more about it, it's right here. Other than Coursera and Harvard, I also know that Brilliant.org has a few programming courses that are also pretty good. I have not personally used Brilliant.org, but from what I've seen of it, I have a few friends who use it. It's very effective.
Remind me again, but you have a roommate who's also at UW-CS, right?
Yes.
Do you guys like ever work on projects together?
So far, not yet, but once we get to higher level computer science classes, we might have group projects, and if our courses match up, then we could make, I guess, pretty good group partners. He also has his own like hobby programming too. Like he likes to like write mods for the video game Terraria in Minecraft in his free time. So I mean, if I get a bit more time, I could maybe like work with him on one of those. I remember like modding Minecraft when I was in middle school, and that was always fun.
What was the mod about?
I remember it was like custom, like I'm trying to remember what it was, but it's some sort of custom mob AI, if I recall correctly, that essentially like it gave mobs like better pathfinding. Because before, sometimes like mobs in the game, when they would try to chase you down, they would get stuck sometimes. And I remember I made some mods to try to like correct that. It's nothing big, but it was just my attempts to like, practice a bit of Java back then.
So knowing that like obviously Minecraft runs on Java. So how does the process go from writing the code to actually implementing it in the game? Like how do you get Minecraft to take modifications?
Oh, so that's why there's already mod frameworks in the game. I remember when I was doing it, I used Forge, and Forge has like it has API with, that with pretty well documented code that you can use to like write the mods and whatnot. And there's also plenty of YouTube videos that you can use to get started to set up your IDE, for example. I remember I used Eclipse to actually to develop the mod, and you just need to add in like the Forge jar files and all the other dependencies, and you can, start writing mod code from there.
Are there any other questions? Because I'm running a bit dry here. In that case, I guess I just want to wrap up with a few final
Wait.
questions.
I got some more private messages here.
Oh, okay.
So one of these questions is, okay, we already went over that one. Here's another question. Which do you prefer, declarative or imperative programming? So for those of you who don't know what declarative versus imperative programming is, declarative programming, it's basically, it's high level programming. It's describing like, what do you want your software to do and not how you get it. And imperative programming is lower level programming where you're telling the compiler what to do step by step. So for example, if I want to put this into human terms, right? Like if I want my computer to like, for example, like go ahead and like make a pizza, for example, right? Declarative programming would basically just be like write one line, like robot.make pizza, for example, right? Like you're just telling the computer what do you want. You're not telling the computer how you want to get it. On the other hand, imperative programming is when you're telling the computer like what you want the computer to happen step by step, I guess. So on the other hand, like imperative programming for that same process would be, for example, like robot dot, like dot go to Safeway, robot dot like buy dough, robot dot buy cheese. And then you see it's on a much lower level. And I guess I have to say I like both, because on one hand, if you're working on like a large project with many different, subsystems, you don't really want to, spend time working on the low level stuff. So declarative programming is good for that, right? Like you want to just like use the library, use some existing library to like do whatever you want, right? Don't reinvent the wheel. But on the other hand, imperative programming it's also good to know, because you want to know what that library is doing deep down so that if something goes wrong with that, you know how to debug it. And that's that question. See another question. What are the variety of projects you have encountered? I've worked on various things, I guess. Like, for example, when I was at Robotics, it's mostly backend programming, where I write the code for the robots to run. I've also done backend programming for all right. Never mind. Seems we're running a little short on time right here. We have Abraham has a couple more questions to ask. Sorry, I can't really get around to all of them.
Looking back, is there anything you would have done different in your coding journey?
Anything I would have done differently in my coding journey?
Yeah.
That's a good question. I can't say I would have, because I guess I'm happy with where I am right now, and I believe my foundations with robotics, for example, it gave me the necessary frameworks to, work in a team, and also, I guess like share ideas and apply like your programming skills while working in a team. So, I mean, I'm glad with what steps I took.
Before we finish up and hand it back over to Kira, are there any last words of advice to any prospective coders? I know that you're throwing around a lot of words that honestly I've never even heard of, so it gets kind of intimidating. So what would you say to any prospective coders?
Well, what I would say to any prospective coders is it's never too late to get started, of course, right? I mean, code doesn't really matter if you're 2 or 102, right? Like you can, at any time you can get started with coding, it's never too late, right? Like even if you're not planning to become like a programmer, there's still many times when you can apply programming in, in your respective field, right? Like if you're going to study biology, for example, you might apply a bit of code to like sequence DNA, right? To like process like a SAM file and like, for example, like look for certain genetic markers in a genome that could explain certain, for example, like birth conditions, for example. Or for example, if you're studying chemistry, you could apply, programming to like simulating like a chemical reaction, right? To like, for example, like enzyme kinetics, for example, you could simulate that using programming also. If you're taking or if you're taking like math, right, you could use a bit of MATLAB and Python to like, do the number crunching for you. Or even if you're taking like social sciences, for example, you could use like big data modeling tools on Python. You could use like NumPy, for example, and SciPy to, process that data, to process like survey results and do the number crunching for you. So it's never too late to start. And there's no one way to start being a programmer, right? Like you could start with like learning online. You could use a textbook, for example. You could, learn by doing. It doesn't really matter how you code as much as your drive to do it.
All right, back to Kira then.
Okay, yeah, thank you. Okay, so that is it for today's software webinar hosted by Titan Robotics Club, joined with Victor Du. We hope you were able to learn more or get inspired. And if you want to rewatch this webinar, be sure to check out our YouTube channel at TRC492 and check out our Instagram at IS Titan Robotics for future news or updates on our club. And thank you for coming, and thank you, Victor, for speaking today.
Thank you, everyone. I'm really honored for you to have me here. Thank you.
Thank you.